I've been experimenting with printing model rocket nose cones out of polyurethane or thermoplastic polyurethane, otherwise known as TPU. This is a flexible material. It can be, depending on how you print it, it can be super flexible like that, which is a thin wall without infill, or you can make it actually rather stiff like this, which hardly bends, but it's still flexible. That's with infill. And this material is, as you can see, elastic, but it's a plastic. And for small Estes style rockets, this can work very well because there's not a lot of stresses on it. I have been using this for rockets powered with E and D size motors. So again, depending on the thickness of the material that you use, the wall thickness when you print it, you can make it harder or softer. And then if you add infill, like you can see in this one here, you can actually see it because it's translucent. You can see the infill inside. It can be even harder. So you can truly print the hardest that you want. Now this is the only PLA one. Of course, this one is super rigid. You're not going to bend that at all. This is kind of the go-to thing for most rockets. But for example, on my tri-gyroc rocket, this is a newer version, a helicopter recovery. This thing comes nose down, so it's really practical to have a flexible nose cone, otherwise it would break. This is actually one of the designs, which is identical to the PLA one. This one here I purposely made fairly stiff with infill and a rather thick wall, but it's still very flexible, as you can see. But I'll ultimately probably fly it with this nose cone here with about this flexibility because I want it to be a big bumper shock absorber as the tri-gyroc comes down vertically like this and it hits nose first. You all may remember this whirly gig that I built that never really worked very well, but I also have a TPU bumper on it that slips over the rocket, and that protects very well the rocket as well. So printing all these nose cones in TPU is fairly straightforward. You have to print it much slower than PLA, but otherwise the parameters and temperatures are about the same. It does get a little stringy, so you got to be careful with that. And as far as TPU filament goes, there's different hardnesses. So there's some like NinjaFlex, which is super flexible. I think it's like a hardness of like 80. That's not recommended for nose cones. This is like TPU 95, and again, it can be you can control essentially the flexibility and the hardness by how thick the wall thickness, and then the infill. And so it's again, for Estes type of rockets, this stuff would work fine. For high power rockets, it's going to be too soft and too flexible, and it'll flutter and probably self-destruct. At least it'll self-destruct the rocket.